Hello friends, welcome back to my YouTube channel Nesting Padasale. From today onwards, we are going to practice few problems for our BARC OCS Biosciences examination. First problem is from mitotic index. Mitotic index is a measure of cellular proliferation. It will be giving a number of cells that are undergoing a process of mitosis. Okay, so mitotic index is a number of cells undergoing a mitosis divided by total number of cells. How you will be calculating mitotic index means mitotic index is equal to total number of cells undergoing mitosis, that is total number of cells in prophase, metaphase, anaphase, telophase divided by n. Okay, n in the sense total number of cells. This include how you will be calculating n means number of cells in mitosis plus number of cells in interphase. The mitotic index for cancerous cells will be very much high. At the same time, mitotic index for those cells that are undergoing a process of rigorous division, for them also mitotic index will be very much high. So here the question is that you have examined 10,000 cells in a culture and found that only 2 cells were in mitosis. Therefore, the mitotic indexes. Okay, as I mentioned you earlier, what is meant by mitotic index? You need to first calculate the number of cells in undergoing mitosis, and then you need to divide them by total number of cells. So here the number of cells undergoing mitosis is only 2 and total number of cells is 10,000. So that mitotic index is 0.002. Okay, so this example you can able to find like that. They will be taking a record of various cell undergoing process of various kind of cell division, cellular spaces. First, they will be calculating number of cells in mitosis, which they can easily calculate by counting the number of cells which have a visible chromosomes, and then they will be calculating number of cells in interphase. Okay, those cells which don't have any visible chromosome. So here in this particular diagram, totally 20 cells were in mitosis and 55 cells were in interphase. So how you will be calculating mitotic index? 20 divided by, and total number of cells include cells in mitosis plus interphase, which include 20 plus 55. If you calculate the mitotic index for this particular problem is 0.267. Next is from animal system physiology animal with regarding to lung capacity. The vital capacity of the individual is 4,900 ml and the tidal volume is 500 ml and the inspirated reserve volume is 3,300 ml. The expirated reserve volume is what? If you know the formula already means you can able to easily apply. See, this formula is universal. Okay, vital capacity is equal to inspirated reserve volume plus tidal volume plus expiratory reserve volume. So from that you can able to easily calculate the expiratory reserve volume. Okay, so memorize the formula. VC is equal to IRV plus TV plus ERV. There are other formula I had listed over here. If they had given inspirational capacity means then you need to apply this particular formula for calculating the expiratory reserve volume, and there are two formula for total lung capacity. So please try to memorize these problems. Next is from ecology, Lindman 10% law of energy transfer. It was given by Raymond Lindman in the year 1942. It is called as 10% law. Why it is called as 10% law means this law states that only 10% of energy in a food chain out of total energy is transferred from one trophic level to another trophic level. Remaining 90% of energy will be either utilized in that particular trophic level or some energy will be released as a heat. If you take this particular, see, for primary producer, the energy level is 10,000 kilocalories. Okay, from this 10,000 kilocalories, only 10% of energy alone will be transported to next trophic level, that is primary consumer. In that case, you need to divide this 10,000 divided by 10, therefore you will be getting 1,000. So 1,000 calories alone will be transported to next trophic level. Remaining 90% of energy will be released as a heat, or it will be used. It will be utilized the organism that is present in this particular trophic level. Okay, so the final trophic level, that is for tertiary consumer, only 10 kilocalories will be available. The question is that a typical food chain involves producer, herbivores, primary carnivores and secondary carnivores. Based on this Lindman law of trophic efficiency, a producer have 40 kilojoules of energy, the energy that will be stored in secondary carnivore. So first is producer, this is the first trophic level, then herbivore, then primary carnivore. The top trophic level is coded by secondary carnivore. The energy energy efficiency of producer has given it is 40 kilojoule. Then what might be the energy of herbivore? It is 4 kilojoule, which means you need to divide 40 by 10, which is 4, and the energy efficacy of primary carnivore is that it is 0.4 kilojoule, which means you need to divide 4 by 10, which is 0.4. And what about the energy that will be stored in secondary carnivore? It is 0.04 kilojoule, that is you need to divide 0.4 by 10, which means you will be getting 0.04 kilojoule. Next is with regarding to degree of reduction. So degree of reduction is nothing but it is the number of equivalent amount of available electron per gram of carbon. And this is a formula to calculate the degree of reduction for any organic compound. Degree of reduction is equal to number of electron. First you need to calculate the number of electron divided by number of carbon atom. So this is one example, degree of reduction of lactic acid is a given. So here in the molecular formula has been given, so that is no problem. So first you need to calculate how many electrons are present in lactic acid. So for which you need to know the valency. The number of electron in carbon is 4 and H is 1 and oxygen is -2. So oxygen, why it is -2 means instead of donating the electron, oxygen will be accepting the electron. That's why the number is -2. And here you can be able to find the number of available electron for sulfur, which is 6, phosphorus, which is 5. Okay, you can have a look on that. So first you need to calculate number of electrons. So you need to apply in this particular formula, that is there are 3 carbons, so 3 into C plus 6 into H plus 3 into O. So the valence of carbon is 4 and hydrogen is 1 and oxygen is -2. So from which you can be able to calculate the number of electron, which is 12, and number of carbon is 3. So how you will be calculating degree of reduction? Degree of reduction is equal to number of electron divided by number of carbon. So 12 by 3, which is 4. Okay. Next question is that you need to find the specific growth rate if they had given doubling time, or else if they had given doubling time, if they had given your specific growth rate, means you need to know how you need to calculate the doubling time. For both for finding the doubling rate or finding the specific growth rate, this is a universal formula. Doubling time, which is G is equal to 0.6931 divided by mu. This mu is your specific growth rate. If they are asking you to find the generation time, means then mu is equal to 0.6931 divided by doubling time. So first problem is specific growth rate of yeast having a doubling time of 0.693 hour is thus. Okay, so doubling time will be, the unit of doubling time will be hour. Okay, within how many hours the organism is double, and the unit of the specific growth rate, which means the growth of organism under specific condition, the unit will be per hour. Okay, you need to note down that particular unit. Okay, they had given doubling time, which you had applied in this particular formula, means you can be able to easily calculate the specific growth rate. So specific growth rate is 1 per hour. Okay. So next, with regarding to this particular thing, the specific growth rate of microbe is 0.25 per hour. Find out the doubling time. Okay, so as I mentioned you earlier, you need to apply in this particular formula. Here they had given the specific growth rate, so 0.6931 divided by 0.25, which is 2.77 is the doubling time for that particular microorganism. So as I mentioned earlier, doubling time should be in hour and the specific growth rate should be in per hour. So here they have given doubling time in 40 minutes. Okay, so the doubling time of microorganism is 40 minutes. What is the specific growth rate? Okay, so first itself you can be able to convert this into hours, or else at the last you can be able to convert. So follow the rule that I am going to tell you. The doubling time is 40 is equal to 0.6931 divided by mu. Mu is the specific growth rate which you want to find. Therefore, mu is equal to 0.6931 divided by 40, which you will be getting 0.173275 per minute. Okay, but we want our specific growth rate to be in per hour. What you need to do means you need to simply multiply this. You need to convert the minute into hour, which means by multiplying to 60. Okay, if you multiply means you will be getting the specific growth rate in per hour value. Okay, next is with regarding to blood grouping. So in the next video we will be continuing this particular blood grouping. Thank you friends, thanks for watching this video.